We're going to be doing a bunch more graphing today, so like I said, if you need more graph paper, it's right over there. Here we go. We are ready for the last two problems on the back of page 12. By the way, on your quizzes, different quizzes had different functions to tell if they were one-to-one. Some of you had the exponential function. Is it one-to-one? The exponential. The exponential is one-to-one. Some of you have the logistic. Is it one-to-one? Yep. Some of you had the sine curve. Is it one-to-one? No, the sine curve is not one-to-one. And the ones that are one-to-one are because they pass both the vertical and the horizontal line test. The sine is not one-to-one because it does not pass the horizontal line test, right? Okay. All right, now, remember what we're doing here. We're taking this random generic picture, same one we used yesterday on all the rest of those problems. There's two more here we're doing. And we're moving it, flipping it, whatever the directions tell me, or whatever the problem tells me to do. So this problem has no numbers in it. So I'm not going to move this picture in terms of picking it up and moving it up or down or something. What am I going to do to it though because of these negatives? What do negatives do? They flip it. So this negative would flip it across X, upside down in other words, and this negative flips it across Y. Now, it makes no difference which you do first, but in some problems it does. So let me just suggest that you follow your regular order of operations. You'll never be wrong if you do that. In this problem, you don't have to do that, but if you just get in the habit of doing anything, you'll never be wrong. So order of operations, PEMDAS, says do parentheses first. So I'm going to flip this guy across the y-axis. So in other words, everything on the left side is going to the right. Please graph along with me, guys. You got to be able to do this on your own. Next quiz we have will be this kind of a quiz. You'll have to graph some stuff. So there I am, flipped across the y-axis. Does that look okay to everybody? Would you agree with that? Now I'm going to go across across the x-axis, which means I'm going to tip everything upside down. So this little guy, instead of going down, is going to go up. I'm going to kind of erase as I go so I don't get confused. This one is going to go down. This one's going to go down. And this one's going to go up. Some of you can do that all in one step, and that's great. I can't. I always do everything one step at a time. But ultimately, that's the picture you got to end up with. So however many steps it takes you to get that, that's what it takes. Everybody good with that? Now this last one is really crazy because there are three things happening in this problem. What are the three things that are happening in this problem? What is this doing? Across X? Or upside down, however you want to say it. This is across X, upside down. What's this doing? One unit left. And this is going through down. So again, as many steps as it takes you to do that. It's going to take me 3 steps to do that. So the first thing I'm going to do, I'm going to follow my order of operations, PEMDAS. I'm going to do parentheses first. So the first thing I'm going to do is move this guy 1 unit to the left. So I'm going to take my original picture and I'm going to move everything 1 unit to the left. Sometimes kids find colored pencils helpful when you're doing like more than one thing. Doesn't matter, you can erase, just make it bolder, whatever works for you. So there I am, 1 unit to the left. Now what do you think I'm going to do next if I'm following PEMDAS? Well, there's no exponents in these, but I did the parentheses. So next would come any multiplications, and this is like a multiplication. This is like a -1. So I'm going to do that next. I'm going to flip it. So upside down we go, right across X, upside down. So here's that one. So I went left 1, and now I've gone upside down. And now the last thing I have to do is take it down 3. So every point is going 1, 2, 3 down. There is my answer, the black one on the bottom. You okay with that? So there are basically 4 kinds of transformations that we have to know how to do. One is when we add or subtract, and that we practiced actually earlier in the chapter. We're pretty good at that. We know how to handle adds and subtracts. Then we have to know how to handle negatives. Well, we're getting that now. Negatives, depending on where the negative is, we either flip this way or we flip this way. Negatives mean you flip, right? So now we're ready to talk about the next kind of transformation, and that is the multipliers. What happens to your picture when you put in a multiplier? Now we haven't done that yet. If you look at the next section, the very first problem says we're going to sketch 2g of x. So we have a multiplier out here. That is not g of x plus 2. That's 2 times g of x. And the picture that we are starting with as our original, and again, there's nothing special about this. This is just some random picture I made up so we could get some practice. So I have a triangle, a semicircle, and a trapezoid. That's our original. Now, we are going to multiply it by 2. Does anyone have any idea what that does? It's called a vertical stretch. So this 2 makes your picture twice as tall. So in other words, see this little triangle here? Instead of going up to 2, he's going all the way to 4. It's called a vertical stretch. Nothing's changing this way. The triangle is still too wide, but he's now twice as tall. This number makes it twice as tall. So see the semicircle? He is 1 high, so now he's going to be 2 high. And the trapezoid was 1 down. Now he's going to be 2 down. So a number out in front changes your height. It multiplies your height. So if that had been a 3, everything would be 3 times as tall. What if it were a 1/2? It'd be half as tall. That number multiplies your height. Whatever is in this position multiplies your height. So let's look at B.
Maybe a plus.
What?
Oh, no.
Well, now B, watch it now. B has a negative and a half. So what does the negative do? Flips you upside down. What does the half do? Half as tall. So we go, hello. So we're going to go upside down, and we're going to be half as tall. Everybody okay? Now, I think maybe even I can do that one all in one step. Again, there's no pressure here. Do it as many steps as you want. But I think this picture is easy enough I can do it that way. So this was my original, right? So I'm going to go upside down and half as tall. So see that triangle right there? It's going up 2. What's it going to do now? Down 1.
Oh, the negative, yeah, you're right.
Now, see this semicircle? It's going up 1.
So where are the points though?
What points?
Like I'm confused.
The triangle did, okay, so it's over here on the left side. It did go up, it was too wide and went up 2.
Okay.
Well, now it's still too wide, but it's going down 1. It's half as tall and upside down.
Okay.
So if it went up before, it's going to go down. So the semicircle, I'm not changing the width of it, I'm changing the height. So how tall is the semicircle originally? 1. Now it's going to be a half, and it's going to be upside down. So it's still too wide. We haven't done anything to change wide. It's all about how tall it is, and upside down. All right, tell me about the trapezoid. In the original, it is underneath, and it's 1 tall. So now it's going to be on top, and it's going to be a half tall. It's still the same width. We're not changing the width at this point. We're just making it half as tall and turning it upside down. Now, if that was confusing in 1 step, do it in 2. So turn it upside down, make it half as tall. Turn it upside down, make it half as tall. Now this next one. Notice that the 1/2 is in a different spot. So if this made it half as tall, do you have any idea what that might do? Change this direction?
Yeah.
Here's the tricky part. I want you to think about this, because it really makes sense if you think about it. When we do f of x plus 3, that actually goes up 3, right? But when we do f of x plus 3, that actually doesn't go right, that goes left. So in the parentheses aren't we already kind of used to it going the opposite direction, we think? Right? This is in the parentheses, so it does the opposite of what you think. You think it would make it half as wide. It doesn't. It makes it twice as wide. This makes it twice as wide. This number, whatever number is here, actually divides the width. It doesn't multiply the width, it divides the width. And you know, as seniors in high school, that dividing by a half is the same as timesing by 2. So we are going to have this exact picture. There's no negatives, nothing's flipped, there's no adds and subtracts, nothing's moved. We have this exact picture, but it's twice as wide. So if the triangle was 2 wide, it's now going to be 4 wide. So 1, 2, 3, 4. Now what about the height? Doesn't change, that's right. So now I got a triangle that's 4 wide. So it looks like that. Would you agree?
Yeah.
Put the point of your triangle right in the middle. So in the beginning, the middle was 1 over, but now it's got to be 2 over, right? Now what about the circle? Well, it's still 1 tall, but now it's,
2 wide.
well, yeah, the whole thing's 4 wide, right? Still 1 tall, but it's now 4 wide. And the top of the circle was at 1, so now the top of the circle is at 2. Now my trapezoid, I'm still only going down 1. But when I did it originally, I went over 1, right, for my first point. Well, now I'm going to have to go over 2 for that first point. And then over 2 more, and then over 2 more. Because it's got to be 6 wide. Would you agree? So if you take 1 step sideways in the original, you have to take 2 steps in that picture. If you take 1 step in the original, you got to take 2 in the new one. So let's back up, make sure everybody's got this. A number out in front multiplies the height. A number inside divides the width. That's a divisor. So I divided by a half, which is the same as timesing by 2. Oh my, look at D. What is happening in D?
You do 2 up and it's a
Well, when you say 2 up, you're not quite saying that right.
2 high.
It's twice as tall.
Twice as tall
So
and
it's
a third
2
shorter.
times as tall.
Twice as shorter than the third.
And 1/3 as wide. Does that make sense to everybody?
Yeah.
So I would suggest that you look at this triangle right here and you say to yourself, okay, how tall is it right now? How tall is it? The original triangle is 2. So the new one I draw is going to be 4. How wide is the original triangle? How wide? How many steps is that? Isn't that 2?
Yes.
So how wide is the new one going to be?
1/3 as wide as 2.
So 1/3 of 2, which is 2/3. So your triangle, here's your graph paper. Your triangle is only going to be about that wide. That's 2/3 wide. But it's gonna be all the way up at 4. You got a super skinny triangle. He's only 1/3 as wide as the original, so he's 2/3 wide. So he's not quite to 1, and he's all the way up to 4. Very skinny. Now, what about our circle, our semicircle? Well, how wide is he originally? 2. So we're going to cut that by 1/3, so he's going to be 2/3 wide. So here's my circle, it's going to be right in here. How tall is he going to be? Well, he's got to be twice as tall as he was. How tall was he? 1. So now he's going to be 2. So I have a semicircle that's only that wide, but it's up 2. Well, it doesn't look very semicircular. There it is. All squished up, right? Stretched up this way, shrunk up this way. Now, what about that trapezoid? How wide is he originally? How many steps here? 1, 2, 3? These 3 across? So now he's going to be how wide across? Whoa, whoa. He's 1/3 as wide. So he's only going to be 1. So he's going to go from here to here. And he's going down. And how far down is he going to go if he has to be 2 times as tall? So I got to draw my trapezoid all the way down here like that. So I did this one shape at a time, and I remembered that for every shape individually, I did one shape at a time, but every shape had to be twice as tall as it originally was, but only 1/3 as wide as it originally was. Ava?
Do you want us to write the points?
You do not need to, as long as it's on a grid. The only time you have to label is when you're like I'm sketching it without a grid, so I should be labeling those. You're on graph paper, so I can tell if it's the right size or not. And some of these points get a little crazy too. I don't want you to stress too much about it. All right, what's next? E. All right, so let's look at this and talk about, before we start, let's talk about what we're going to do to it. What are we doing to this picture? What is this negative doing? Flip it which way?
Across the y-axis.
Across the y-axis. So this is going across y. All right. Now I put a 2 there. Now look where that 2 is. It's inside the parentheses. So what's that going to do, that 2? It's going to divide the width, right? So isn't this going to be half as wide? So every piece of this is going to be half as wide and flipped sideways. So, see this triangle right here? He's ultimately going to be over here on this side. Would you agree? And he's only going to be half as wide. So how wide is he right now? 2. So that triangle is only going to be 1 wide. And on that side of the y-axis. One step at a time. Now let's look at the semicircle. He's on the right, so I'm going to actually draw him over here on the left, right? How wide is he originally? 2. He got halved. So he is going to be 1 wide. So there's my semicircle. 1 wide on the other side of the y-axis. Now, my trapezoid is going to be over here too, right? How wide is he? He's 3. So when I draw him, I'm only going to draw him 1.5. So 1.5 would be like right here. That's where he's going to end. And his trapezoid just in that much space. There is a lot to keep track of, but if you do it one step at a time, I think you'll be okay. Very good. All right, F. We don't have any stretching or shrinking going on in F. What's happening in F? We're flipping everywhere, right? Do I have a volunteer? Does anybody think you can draw that picture? Thank you, Bo. Yeah, absolutely. Yep, that's right. So reflect it. And again, there's 2 things going on, so feel free to do it in 2 steps. If you can do it in 1, do it in 1, doesn't matter. We have erasers, we can erase, we can use colors. That's our picture right there, yeah. So what did Bo do first? Which reflection did he do first? He did the one across the y-axis. He worked inside his parentheses first. Now what's he going to do? Yep. So here's his blue marker. He's just turning it upside down. He's got it. He made a little bit of a mistake. I don't know if any of you caught that, but he caught it. He's fixing it. Now you want to erase your black one. He had me a little worried at the beginning, but I think he did a great job now. That's right, that's how you finish. Anybody have a question about that or concern? You think that looks okay? Everybody got it? Everybody able to do it? We will not have a quiz next time, but we'll have a quiz the next time when you have to draft. So start getting this stuff organized in your head. All right, one more here. Let's see. Oh, we got tons of time. Good. One more in this section. Oh my gosh, what is happening in H? What are we doing in problem H? Any thoughts? What? What kind of stretch? You're right. Vertical stretch. So this says we're going to be twice as tall. I like to write it down in words to remind myself. You don't have to do that, but this means twice as tall. What does this mean? Right one, and this means up two. Okay, so here we go. Where do you think I'm going to start? There is no way I can do this in one step. So where do you think I'm going to start? I'm going to start right here, right one. Why, Mrs. Ford, are you starting with right one? PEMDAS. It's inside the parentheses. So I'm going to go right one. So I'm going to take that picture and I'm going to go up, or excuse me, right one. So right one moves my triangle like this, and my semicircle like this, and my trapezoid like this. Is that okay with everybody in terms of right one? Magnus, you look like you're in agony. Does that make sense to you?
It does.
Okay. So we're right one. Now I'm going to make it twice as tall. Once I do parentheses, I'm going to do my multiplication. So I'm going to make it twice as tall. Nothing is moving. I am simply making everything twice as tall. So see how this triangle went up 2? Now he's going up 4. The circle is going up 2, and the trapezoid is going down 2. So I'm going to take out my black one now. I have doubled my height. I have made it twice as tall. Now what am I going to do? Every point is going up 2. So on graph paper, that's real easy. Just pick up every point 2 units. So now this one's all the way up at 6. So here's my triangle. Here's my circle. And here's my trapezoid sitting right there on the x-axis. So the black is the final answer to the problem. Okay, so I said there were 4 kinds of transformations we have to know. The first one we learned a long time ago is adding and subtracting, like these right here. These are your movements, right, left, up, and down. The next kind is negatives. Well, we learned how to handle negatives. Negatives do your flipping. We just learned how to handle multipliers. Multipliers change the width or the height depending on where they are. Out in front is a height thing. In the parentheses is a width thing. The last,
For the quiz, can we bring in colored pencils?
oh yeah, you always can use colored pencils. The last kind of transformation we have to do is the absolute value transformation. So we're going to use this same picture, but now we're going to apply absolute value. And just like with everything else, there's 2 ways you can do absolute value. You can do it like this, which is the absolute value of the whole shebang, or you can do it like this, which is just the absolute value of x. Okay, this is the last one you have to learn, guys. It's pretty easy. When you do the absolute value of the whole picture, it simply makes everything, every y, the g of x, every y value positive. So you see this triangle right here? It's already positive. These y's are already positive, aren't they?
Yeah.
And these y's are positive,
So it just.
but these aren't. So it makes these y's positive, so it folds it up. When you do this kind of absolute value, everything goes above x-axis. Everything gets folded up. Now, if it's already there, it stays there. So the triangle is already above. The semicircle is already above. And now the trapezoid comes up. That's all there is to it. When you do the absolute value of the whole problem, it takes everything below and folds it up. It doesn't change the parts that are already up there. It just brings the bottom up. Last year, in fact, some kids said, oh, I'll think of that as bottoms up. Okay, if you want to think of this as bottoms up, that's what it is. Okay, everything on the bottom comes up. This one is a little bit trickier, but just as easy. When you have to draw the absolute value of just x, I want you to reproduce the right side of the picture. So draw the right side of the picture exactly as it is. Do not change a thing. Draw the right side of the picture just like it is, just the right side. Got it? Now, reproduce that on this side. In other words, take that right side and redraw it on the left.
So you don't even care about the
Nope. The original left side disappears. That is the picture. When you do the absolute value of just x, you draw the right side and then reproduce it on the other side. Mirror image it on the other side. The triangle is gone. Anything that was over here is gone when you take the absolute value of just x. So, recap. If we have the absolute value of the whole thing, everything on the bottom comes up. If you have the absolute value of just x, the right side stays exactly the same, and then it is reflected over onto the left side. Okay, Matthew? Boy, you don't look like you're real excited by this. Let's see. Maybe this next problem will be exciting. What are we going to do with this next problem?
3 for C.
C. Yep, we're on C.
Flip it up and go up 1.
Exactly. Flip it up and go up 1. So the absolute value takes the original picture and flips everything up. Well, most of it's already up, so here comes the trapezoid. All right, that's my absolute value, right? Everything on the bottom comes up. Now I go up 1. So every point simply goes up 1. And the blue is my answer. Are you okay with that? That's pretty easy, isn't it? Notice I didn't change any size. How do I change the size of my picture? What do I have to have in the problem to change the size of the picture? Multipliers, right? I need multipliers. Multipliers out here to change the height. Multipliers in here to change the width. It takes multipliers to change the shape. All right. What about this one? What's going to happen there, do you think? gonna do my absolute value, which I've already done a couple of times, but I'll do it again. My absolute value, remember, takes everything on top and leaves it there, and takes everything on the bottom and puts it on the top. So that's the absolute value. What happens when I put a negative in front of it? Turns it upside down. So the answer is going to be this.
So if you don't do it in the right order, it'll be different.
Uh-huh, yep, yep. All right, let's do the next one. What am I ready for? E. So I have G of the absolute value of X minus 2. You can describe to me how I handle this. Right side, very good. I draw the right side and then reproduce it on the left side. That's going to be this. So I'll start with that. I've got my semicircle and my trapezoid. And then over here, I'm going to have my circle and my trapezoid. Remember, when we do the absolute value of X, we reproduce the left side, or excuse me, the right side. We reproduce the right side exactly as it is. Exactly. And then reflect it over onto the left side. Now, what does the minus 2 do? Down 2. So I'm going to take that picture and go down 2. Everything's going to go down 2. So I got my circles, and then I have my trapezoids. So the blue thing is the answer. Shooty tooty, we're not going to get this quite done. All right, but we're going to get close. Let's try F. What are you going to do with F? Can you describe it to me? So F is definitely going to involve a doubled height. Would you agree? That means twice as tall. And this means mirror, yeah, however you want to talk about mirror right onto left. Or Emma said double the right side. So we're going to redraw the right side on the left side. And then we're going to make it twice as tall. So we've got our semicircle and our trapezoid. And our semicircle and our trapezoid. Everybody good? Now we're going to make it twice as tall. Not moving anything, just making it twice as tall. So the semicircle's up 2, trapezoid's down 2, on both sides, of course. So the answer is the blue. You okay with that? Oh my gosh, is your brain ready to explode? We got 2 more to do. We'll finish those next time. And then next time we have some word problems to do.